We begin in 1957. Sputnik beeps over a nervous world. A beach ball-sized artificial satellite launched by the Soviet Union orbited Earth every 98 minutes, transmitting radio beeps. In 1969, a clumsy moon boot print is left on the lunar surface by a U.S. astronaut with an American flag that said, "We can do impossible things." The first space race was two superpowers, neck and neck, proving systems. Fast forward. The Soviet program fades. The shuttle retires, and commercial rockets start showing up. Meanwhile, China builds quietly. 2003. First taikonaut. 2011. Congress walls off NASA from direct cooperation with China. Different tracks emerge. 2019. China lands Chang'e 4 on the far side of the moon, first ever. 2020. Chang'e 5 brings lunar rocks home. 2020 also finishes Beidou, their GPS alternative, 2021 to 2022. Modules click together in orbit Tiangong, a new space station with a steady crew, 2022, the U.S. side. Artemis 1 loops the moon in 2022, April 1st, 2026. Artemis 2 with 4 occupants lines up a lunar flyby to the far side. It passes a translanar ejection on day 2, putting Orion on the path to the lunar South Pole by April 6. First landing targeted for 2028, and at least once a year after that, companies race to deliver. Cargo landers, comm relays, and the Lunar Orbiter Gateway, which may be on pause for Artemis 4, as per the new administrator, 2024. China launches a new relay satellite. Chang'e 6 pulls off the first far-side sample return. Power move. Chang'e 7 aiming at the moon's south pole to hunt water ice too. Chang'e 8 to test building things on site. Beijing says put taikonauts on the moon by around 2030 and build an international lunar research station with partners. So, is this the next space race? Kind of. But it's not a Cold War rerun. It's multipolar, commercial, and fast. Here are the stakes. Water ice at the South Pole isn't just science, melt it. Breathe it. Split it for rocket fuel. That's fuel depots and permanent presence. Whoever masters landing, refueling, and building on the moon can own the crossroads between Earth and deep space. Standards matter. Docking systems, navigation, comm protocols. Pick a standard and you pick an ecosystem. Artemis Accords, China's ILRS vision. It's not just flags, it's who writes the rules, economics, lunar deliveries, cis-lunar comms, space tugs, power, mining, robotics. Entire industries could spin up around monthly launches. Security, the line between telescope, radar, and military sensor is thin. Space is transparent, but also contested. Debris, jamming. Rendezvous tech, these cut both ways. Soft power live stream a lunar landing, and millions of kids choose majors the next day. Talent follows inspiration. So what actually decides this? Cadence. Not one giant leap, but relentless, boring reliability. Payloads showing up, budgets staying put, launches that feel routine. Open architectures that let partners plug in. Clear norms that say do this, not that. If the US keeps Artemis moving, empowers commercial players, and makes room for allied missions, it sets the tempo. If China keeps chaining first samples, landers, crews, it sets another. Race or not, the finish line isn't a flag. It's a sustainable neighborhood in cis-lunar space. The real question is, who helps build the streetlights, refueling stations, and the rules of the road? Because whoever does that shapes the century.